Hey everybody, this is the ninth grade math, Algebra 1 summer semester lesson 3-2. And in this lesson we're going to continue with what we were doing in lesson 3-1. In lesson 3-1 we solved solved linear inequalities, and what we're going to do now is we're going to do what's called a system of linear inequalities, which is basically just doing two linear inequalities on a coordinate plane. So basically we're going to do everything we did in lesson 3-1, but we're going to do it 2 times for each question, okay? All right, so here is a list of steps. If you want to go ahead and write them down, I'll talk you through them right now, but you should write them down because I'm going to erase them so they're not going to be here. So what we're going to do here is we're going to do systems of linear inequalities. What we're going to do is we're going to graph both linear inequalities because there's going to be 2 of them. Then you want to check those linear inequalities in Desmos. So you'll, after you graph one of them, you can go into Desmos and then type the graph in and see if it looks the same as what you put on the paper. Okay. And then what we're going to do is we're going to graph the second one. And then after you graph the second one, you're going to go into Desmos and make sure that you did it right because you don't want to get it wrong. And then what you're going to do is you're going to have sort of an X on the page. And once you have the X, that means that there's going to be 4 wedges. And what you're going to do is in each wedge, you're going to pick a single test point. You're going to pick any point, any set of coordinates, one from each wedge. And then what you're going to do is you're going to test each one of those 4 points in both of the inequalities that were given to you. And then you can also check it in Desmos. And then what you're going to do is only one of those 4 points is going to be make both of the inequalities true. And then that one point is in the solution wedge. And so what you're going to do is you're going to shade that wedge. So there's going to be 4 wedges, and you're only going to shade one of them. That's going to be the solution. Okay. All right. So let's try an example. Okay. So here's one. It says graph a solution to this system. And what we have here is we have 2, anytime you have 2 equations or 2 functions that are joined together, basically we call it a system. So since it's not just one line, it's actually 2 lines, it's called a system. Okay, don't get scared off by the word system. It just means that that these 2 go together. Okay, but they are separate. They can be graphed separately. So what we're going to do is we're going to graph y is less than or equal to x minus 5. Then we're going to graph y is greater than negative 2x plus 4. Okay, so let's go ahead and graph y is less than or equal to x minus 5. Well, we know that the first thing we need is the y-intercept, and the y-intercept is going to be 0, negative 5. Okay, so we're going to go to 0, negative 5. 1, 2, 3, 4, 5. So the point's going to be right here. Okay, so that's the first one we're going to graph. Put a point right there. Then our slope here, we can see it's just an x, but in front of the x is a 1. And so we know that the slope on this one, the slope is going to be 1, which we can write as 1 over 1. Okay, so we're going to go up 1 and then to the right 1. Okay, so from here, let's see here. From here, we'll go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. So really, it's going to be these points right here in the diagonal. We're also going to go down 1 and left 1, down 1, left 1. Okay, so that's going to be all those points right there. So we'll have this one, this one, this one, this one, going all the way up. It's a slope of 1. You should get used to the slope of 1. The slope of 1 is the easiest slope to deal with. Okay. Just go straight through the diagonals of all these points, okay? Now what we're going to do is we're going to go ahead and draw our line. So we'll start here, and then we will, oh, why is it doing that? Okay, hang on a second. Let's undo this, and then undo that one. Okay, I think I accidentally did 2 lines. There we go. We can go straight through here, and then we're going to do that, okay? All right, that's a good one. And now we're going to do the other one, which is y equals negative 2x plus 4. So we're going to go to plus 4, 1, 2, 3, 4. So there's positive 4, that's our y-intercept. And then we're going to do -2, a slope of -2, which is, so a slope, remember that a slope of -2 means -2 over 1, and that means down 2 and then to the right 1. So down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, and down 2 to the right 1, same thing. And we're going to go all the way down to here. Then we can go up 2 and back 1, which will be here, up 2 and back 1, up 2 and back 1, okay? Now we'll draw a line through all these points. So we'll start right here, and we're going to draw a line through all these points. And then, there we go. There we go. That's close enough. Okay, cool. So we now have 2 lines. Now, I want to point out that the one we just drew is actually a, so the first one, less than or equal to, this one's going to remain solid, but this one has to be a dashed line because it does not have an or equal to. So remember that. So let's go ahead and switch over to our eraser. Okay, that's not it. Here's our eraser. There we go. All right, and we're going to do that. Okay, and what we'll do is take the eraser and we'll just put some spaces in it. There we go, so that it's a dashed line. Okay, there we go. And now, like I said, what we're going to do now is we're going to go over to Desmos and we're going to make sure that we got these lines correct. We're going to check our work. So I want to do y is less than or equal to x minus 5. So here, I'm going to do y is less than or equal to. Now, how do we do less than or equal to? Well, what we do is I'm going to hit shift and then less than. That'll give me a less than symbol. Then right after I do less than, if I press the equals button, it actually just makes it a less than or equal to. That's really clever, right? So then we're going to do x minus, and then what was it again? It was x minus 4 or x minus 5. Okay, x minus 5. And then here we go. And look, is that the same line that we drew? Well, let's go back to our work, and sure enough, that is the same line that we drew. You can see right here, that is the same line, okay? And you can see that it's already showing us the area that's going to be shaded, okay? But we're gonna get to that later. The other line that we're going to do is going to be y is greater than -2x plus 4. So we're going to click right underneath here. That'll give us another one. Y is greater than -2x plus 4. And look, here it is. It's going through 4, and it's going to go down 2 over 1, down 2 over 1. And sure enough, that's exactly what we drew. Okay, we have a very similar picture, okay? And so now what we want to do is we want to go over here and we want to select four points. Here's what I want to show you. Note where they intersect right here, that there's a wedge above. This is one wedge. This is one region that is cut off by both of them. Then over here, this is another one that's cut off by both of them. Here's a third wedge, and here's a fourth wedge. So we have 1, 2, 3, 4 wedges. What we want to do is we want to select a point, a different point inside each one to test them. So what I'm going to do is I'm going to select a point. Let's see, maybe this one right here. Look, that one. See that point right there? That point is in this wedge right here. And now we're going to select a point over in this wedge. Let's choose this point right here. And down in this third wedge, we'll select that point right there. And over in this wedge, we'll select this point. Okay, so each one of these points are in a different wedge. Okay, so this one right here, that's 1, 2, 3, 4. This is 4, 4, 1 is one of our points. This one's 1, -1, 1, -1. This point right here is 3 and 1, 2, 3, 4, 3, or sorry, -3. Sorry, let me take that back. I wasn't thinking. We're not doing the y, we're doing the x first. 1, 2, +3, then 1, 2, 3, 4, then -4. So +3, and then -4. Okay? All right? And then this point is going to be 1, 2, 3, 4, 5, and then -2. 5, -2. What we're going to do is we're going to plug each pair of numbers into both of these. Okay? So let's start with 4, 1. Okay? We're going to put a 4 in for x and a 1 in for y. So we're going to have 1 is less than or equal to 4 minus 5. We're going to do the same thing with this one. We're going to put a 1 in for y. 1 is greater than negative 2 times the x is 4, and then plus 4. Okay, and then we're going to solve both of them. Here we're going to say 1 is less than or equal to 4 minus 5 is negative 1. And then here 1 is greater than negative 2 times 4, that's negative 8. Okay, we got negative 8 plus 4. That's going to be negative 4. Well, 1 is greater than negative 4, so we're good here. Okay, that's true. But 1 is not, it's not less than negative 1, less than or equal to negative 1. And so therefore, this point, this is not the correct region, okay? So now we're going to have to pick another, we're going to test a different point, okay? Let's erase here. Let's see, I want to do this entire stroke. Let's do that, okay? All right. Let's try 5, negative 2 here. Let's try that one. So we're going to put the 5, it goes in for x, okay, here, and the negative 2 goes in for y. So we'll have negative 2 is less than or equal to 5 in for x minus 5. Okay, well that means negative 2 is less than or equal to 5 minus 5 is 0. Is negative 2 less than or equal to 0? It sure is, so the first one checks out. Now we're going to do the same thing with the y greater than. So the y here is negative 2 is greater than, then we're going to do negative 2 times the x is 5, and then plus 4. Okay. Well, negative 2 times 5, that's negative 10. Okay, so here we have negative 2 is greater than, negative 2 times 5 is negative 10, and negative 10 plus 4, if you do that in a calculator, or just do it in your head, that winds up being negative 6. Okay, and is negative 2 greater than negative 6? It sure is. Now you may be thinking 2 isn't greater than 6. No, but negative 2 is greater than negative 6. And what that means is, since both of these are true, that means that this region is actually our solution region. Okay, and so what we're going to do is we are going to, I don't know if you remember how we did this, we shaded the region. So we're going to go ahead and change this into a shading. There we go. And then we're going to come over here and we can outline this region here, go along here, and then just sort of shade in this region here. Okay, and that is our solution region. Okay, and so now we know that every point in this region is a solution for this system. Okay, so let me clarify here. No point in this region is a solution for this. No point in this wedge is a solution. No point in this wedge is a solution. But every single point in this wedge is a solution for this system. And I'll prove it to you. We'll go ahead and take a different, point instead of negative 2 and 5. Let's take one that maybe is easier to do. Okay. How about over here? Let's do 1, 2, 3, 4, 5, 6, 7, 8. How about 8, 1? 8, 1. That's right here, okay? And so if we have x equals 8 and y equals 1, we're going to change this. Let's change this back to this and this back to this, okay? All right, so what we're going to test is, we're going to test x equals 8 and y equals 1. It's the point 8, 1, okay? And it's this point right here. 1, 2, 3, 4, 5, 6, 7, 8. It's this point right here. That's what we're testing. And it's in the solution region. So let's put it in for y. Okay, so y is 1, less than or equal to, x is 8 minus 5. And that means that 1 is less than or equal to, well, 8 minus 5, that's 3. Is 1 less than or equal to 3? Yes. Okay, check. We're good to go. Now we're going to do the other equation. We're going to put a 1 in for y. Then we're going to say greater than. Then we're going to do negative 2 times x. X in this case is 8. And then plus 4. Plus, good. And so now we have 1 is greater than negative 2 times 8, that's negative 16. Negative 16 plus 4, okay? And so now 1 is greater than, negative 16 plus 4 is negative 12, okay? And is 1 greater than negative 12? Oh, it sure is. And therefore, this one is true as well. And so the 0.81, which is in the solution region right here, does make both equations true, and therefore this is our solution region. Now, if we go to Desmos, we can actually see this solution region. Do you see how when we graph the first one, this is the solution region below the line, but when we graph this one, the solution region is above the line, right? And so when we graph both of them, do you see where there's double overlap of the shading? This is shaded, it's only true for one of them. This shaded region is only true for one of them, okay? But this shaded region is true for both of them, and that makes this the solution region, okay? And that's the end of the question, okay? So maybe we can try another example. Okay, here we have graph a solution to this system, and we have y is less than negative x minus 2, and we have y is less than or equal to 3x minus 4. Now, you could pause the video and maybe try one of these on a piece of graph paper. You're going to have to get your own graph paper from somewhere, maybe use some from one of the worksheets. Okay, so here's what I'm going to do. Hopefully you've already tried it. Hopefully you could do it you could also try it in Desmos and see how it turns out, okay? All right, so what we're going to do is we're going to graph this y is less than negative x minus 2. First, we need the y-intercept of negative 2. Okay? We're going to come over here to negative 2, and we're going to plot the y-intercept. Then here we have a slope of negative 1. So the slope here is negative 1, which is the same thing as negative 1 over 1. And so we're going to go down 1 and then to the right 1. Okay? So here, down 1 and to the right 1. Down 1 and to the right 1, down 1 to the right 1. We're going to keep doing that, right? Okay. There we go. And then we can also go up 1 and to the left 1. We can continue in the same line, only backwards. Up 1 and to the left 1. Okay. Go. And then we're going to draw a line. Okay. So here. Here. There we go. And then this is an or equal to, and therefore we need to make it a dashed line. Okay, so what we're going to do here is we're going to let's see, we're going to sort of put some dashes in here in between. There we go. Doesn't have to be perfect. It does have to be dashed. Oh, that was maybe a little too much there. There we go. Okay, great. As long as we have a dashed line instead of a solid line. There we go. Now we're going to graph this other one here. Let's graph it in a different color. Let's graph it in red. We're going to do y. Y is less than or equal to 3x minus 4. So we got to go to negative 4. So 1, 2, 3, 4. So here's negative 4. Okay, there it is, big dot there, and then we're going to go, we have a slope of 3. So the slope is 3, which is the same thing as 3 over 1. That means we're going to go up 3, we're going to go up 3, and then we're going to go to the right 1. Okay, so from here we're going to go 1, 2, 3, up 3 to the right 1, up 3 to the right 1, up 3 to the right 1, up 3 to the right 1. Okay, I think we stop there. Then we can go down 3 and to the left 1, down 3 into the left 1, and it looks like that's as far as we can go. So now we're going to draw a line through all these points, and then there we go. Look at that. And so now this one is an or equals to, and since it's an or equals to, we're going to leave it as a solid line. Okay. And so if we go over here to Desmos, we can see if we got our lines correct, okay? So negative x minus 2, so y is less than negative x minus 2. And let's see here, does that look kind of like what we did? It sure does. There we go. It's downward sloping, intersects at negative 2, intersects at negative 2, downward sloping, and it's dashed. See that? And then this one is going to be less than or equal to 3x minus 4. Okay, so we're going to do y is less than, and then press the equal sign so we get an or equals to 3x minus 4. All right, and is this what it looks like? Yeah, so we intersect at 4, we go up 3 over 1, up 3 over 1, up 3 over 1. So this looks like the right thing, okay? And so now, when we go back here, we need to select some test points, okay? So we're going to go to, oops, I'm going to grab our pen here, and let's, maybe we'll switch colors. Let's make our test points in, maybe in green. There we go. All right, so we'll choose a test point over in this quadrant right here, and in this wedge right here. Look at this, 0, 0 is in this wedge. Let's select 0, 0 for this one. In this one, let's select maybe this one right here, and in this wedge down here, let's select this point, okay? So we have 0, 0. This one is 1, 2, 2, and negative 2. So this is 2 and negative 2, so we'll try that one. And then this one over here is negative 1, negative 3. Negative 1, oops, I should have done that, hang on. There we go, negative 1, negative 3, okay. And then this point down here is at 1, 1, 2, 3, 4, negative 5, 1, negative 5. There we go. Okay, so now let's go ahead and test 0, 0. Okay, let's put it in the first one. So we'll have 0, we put it is less than negative 0 minus 2. Now I need you to know that negative 0 is just 0. So this is the same thing as saying 0 is less than 0 minus 2. And so that's the same thing as saying 0 is less than. 0 minus 2 is negative 2, and that's true. 0 is less than negative 2, so we're good to go. Now let's do this next one. 0 is less than or equal to 3 times x, which is actually going to be 3 times 0, minus 4. Okay? All right, well, that means 0 is less than or equal to 3 times 0 is 0 minus 4. Well, 0 minus 4 is negative 4, so we're going to say 0 is less than or equal to negative 4. Well, is 0 less than or equal to negative 4? Well, negative 4 is not 0, so it's not equal to. But is 0 less than negative 4? It is not. Therefore, this is not true. And because it is not true, there we go. Because it's not true, then we know that this point is not the correct point, okay? Not correct. So let's move over here to let's try this one right here, which is negative 1 and negative 3, okay? All right, so let's erase all these other ones here. Okay. There we go. Okay, good. All right, so now let's try. We're going to put x is negative 1 in this case, and y is negative 3. So in this first one, we're going to put negative 3 in for y, then we're going to say less than negative, and then x is negative 1. So this is negative, negative 1, which means positive 1, okay? Then we're going to go minus 2. So we're saying negative 3 is less than 1 minus 2, okay? And so that's negative 3 is less than, well, 1 minus 2, that's negative 1. Is negative 3 less than negative 1? It sure is. So we're good there. Now let's do the other one. We'll go negative 3 is less than or equal to 3 times negative 1 minus 4. Okay, well, that means negative 3 is less than or equal to 3 times negative 1, that's negative 3 minus 4. Okay? And so now we're going to say negative 3 is less than or equal to negative 3 minus 4, that's negative 7. Well, is negative 3 less than negative 7? Oh, it's not. So this is definitely not it. So this one, not correct. This is not the right one right here. Okay? All right, well, let's try this one down here, 1 and negative 5, and see how that turns out. Okay, x here is 1. And y is now going to be negative 5. Let's erase this other stuff. Okay. All right, good. All right, so let's choose our green pen. Here we go. All right, so 1, x is 1, y is -5. All right, so let's do the first one. -5 is less than negative of 1 minus 2. Okay, well, negative of 1 is -1. So -5 is less than -1 minus 2. Okay. Minus 2. And that means -5 is less than -1 minus 2 is -3. Okay? And -5 is less than -3. So we're good. Now let's try the other one. Y is -5 less than or equal to 3 times x. X is 1 minus 4. There we go. So we have -5 is less than or equal to 3 times 1 is 3. 3 minus 4. Okay, so -5 is less than or equal to 3 minus 4 is -1. And is -5 less than -1? It sure is. And so look, we have 2 green check marks. That means that this one is good. This is in the solution zone, and that means this wedge right here is the solution zone. So we can shade this whole thing in, and every point in this region is the solution. Now I can show you that if we go over to Desmos, that is the double shaded region. See, look at this. Here's the double shaded region. Over here, only one of them is true. Over here, only one of them is true. But down here in this wedge, both of them are true, and therefore this is the shaded region, and that is our solution, okay? And so that's all we're doing in this lesson is all I want you to do, I think there's 8 of them, where you just draw one curve or line, you draw another line, and then you shade the correct region. And make sure that you're making the line dashed if it doesn't have or equal to, and make sure you make it solid if it does have an or equal to, okay? And that's it for lesson 3-2.